videos. Take your handy dandy highlighter, and I'll do it in purple. And we want responded. So that'll be these guys. And I'll do a blue highlighter. And that'll be age of 22 to, and we'll do a red highlighter, to 39. So those are your numbers. Now all you have to do is add them up and subtract the what? The overlap. If you was not here Tuesday, we need to go over Tuesday's video. And we're going to add up all the purple. So we get a purple marker. And that'll be 79 plus 261 plus 251 plus 142 plus 144 plus 208. And that's our purple highlight. And then the blue highlight plus 261 plus 22 plus the red highlight of 251 plus 35. And then I'm going to take a brown highlighter or a brown marker, and I'm going to highlight, and I'm going to put a circle around that number and around that number, because that is our what? Overlap. So we're going to subtract the overlap, and that's going to be 261 plus 251, and all of that is going to be over whatever all of them added up is. Somebody tell me what that number is. I heard 1279. Thank you. 1279. Now when you do all that number crunching, what do you get round to how many places? We need to talk about this, because some of y'all are not reading what? Directions. And you get mad when you get them wrong on tests. It says plain as day on most of these questions to round to a certain decimal place. Okay? What do you come out with? Say it one more time. 0.694. Won't be 1. Be between 0 and 1. How about 0.893? Somebody give me a second on that. Okay? So you got an 89% chance if you put every one of these people on a piece of paper and what they are, if they refused, if they're 40 to 49, or whatever the case may be, and these 1,200, you have 1,279 slips of paper. And you put them in a box and you shake it up and you pick one piece of paper out. You've got an 89% chance that it's going to be a person that responded, or 22 to 29, or 30, whatever, 39, or whatever. And what law is this? The addition law. You're adding the probability. All right? And you're subtracting the overlap. You feel good about it? Cheer up. Gosh. All right, let's talk about 4.4. I think this is 4.3.
Yeah.
No, tough. You done missed it. What, you got a question?
I came out with the right answer, but, you know, I had 1085 plus 22 plus 35. That was 1142 divided by 1259.
Yeah, you just cancel them out. That's fine. Just be careful and don't forget to do, just don't forget to do it. Because the way that I show you, you don't forget because you put it at the end. Okay? No, I said, just don't forget to take out the overlaps. Because on a time test, things run together sometimes. All right, 4.4, we're talking about the multiplicative law of probability. Now, the multiplicative law basically revolves around the word and. So instead of saying the probability of this or this, it's going to say the probability of this and this. Now there's only two things that you need to remember about the multiplicative law, and that is with replacement without replacement. Now, when you're dealing with replacement, the probability is not affected. In fact, you might want to leave a little bit of space between the two. This is called independent. I don't care about that, but it's in your book. I think it's on like page 107 or something. You all look in your book and see it. Independent. Meaning that the probability is not affected. The best way to explain with replacement is a bag of marbles. Okay? You got 3 red marbles, 4 blue marbles, 5 green marbles, and 4 yellow marbles. Okay? And if I tell you that I want the probability of picking a red marble and a blue marble. Probability of a red and blue marble. Well, red and blue, you're talking about the probability of red would be 3 out of 16, right? I mean, add them all up. 9 and 7, isn't that 16? So the probability of red would be 9 over 16 times the probability of blue, which would be what? 4 over 16. And then you multiply those two together, and that gives you the probability of picking a red and a blue marble. But there's one small problem. You got to specify whether it's with replacement or without replacement. Because if it's with replacement or without replacement, then you got a totally different problem. Let's say that I ask you, what is the probability of picking 2 red marbles? Probability of picking 2 red marbles, and this is without replacement. What does without replacement mean? That means that when I pick the first marble, whatever color it is, I put it in my pocket. Pick the second marble, put it in my pocket. Pick the third marble, put it in my pocket. Well, how many did I say? 2 reds. I pick, I reach my hand in the bag, I pull out the marble, put it in my pocket. Reach in, get another one, pull out, put it in my pocket. Now, the whole act of going in, pulling out a marble and putting it in my pocket, that's going to be the same for any color, right? So I'm just going to use that technique with the first 2. I want to see what is the probability of them being red. So I will start off with 3 out of what? My next one will be something over something, but it's not going to be 3 over 16 because one of them is in my pocket. 2 over what? Need to write that down. That is without replacement. Why is the probability affected? Or can you explain to me how the probability is affected? Okay, somebody should be able to answer. Exactly. The first number that I did was 15 over, or 3 over 16. Well, the second number is totally different from the first number. So each time the domain is affected because not only is the numerator changing by 1, but what? The denominator is changing by 1 also. So each time you're going to get a different probability number because of it's dropping by 1. Versus with replacement, probability, somebody give me this to 2 decimal places. What's 3 over 16 times 2 over 15? Everybody get 0.03? I'll tell you what, give me 4 decimal places and I'll tell you why in just a minute. 0.03 what? 0.03 what? Okay. Okay, 0.025? Okay, I'm sorry, y'all changing gears on me. All right, now, if I did 2 red marbles with replacement, what does that mean? Am I going to put them in my pocket when I pull them out, or what? I'm going to put them back in the bag after I record what I pull it out. But it affects also if I'm thinking about pulling all reds out. It's going to change. So, I mean, it's not going to change because if I pull 1 marble out and record it and put it back in, does the denominator change? No. Does the numerator change? No. So, what's the probability? Well, it would be 3 over 16 raised to the what? That's the power, or 3/16 times 3/16. So crank that out and give me 3 decimal places. What do you get? I'm sorry, what? 0.035. And what do you see? What do you see?
The difference you
Yes, that's right, class. A difference. Will it always be different? No. And that's what I tell students, and this is a Hubertism, so you're not going to see it in your book at night. I don't know. I don't read the book that much. You probably tell that. Anyway, with replacement and without replacement, both increased with similarities with white with large numbers. Did I have large numbers or small numbers with the bag? Small numbers. So your difference is going to be greater. Your similarity is going to increase, or your equality is going to increase as your numbers get bigger. And I usually tell students 3 digits over 200. Now that's a very general rule. It's not written in stone, but I usually tell students if you have a numerator and a denominator over 200 apiece, in other words, over 200 on the numerator and over 200 in the denominator, you will see that there is no difference between with or without replacement. I don't understand. Why is everybody in bad mood today? All right, so let's take a. Now, the reason I didn't put dependent and not the probability is effective, or is not effective. What did I say? This is effective because if this one is independent and not effective, what is this one? Dependent and effective. So I didn't put that. So I'm sorry. I figured y'all could take care of that. Let's go ahead and look at a problem. Here. And I'm going to pull up a problem and we will do a simple one first. We'll get Mr. DeVoe to show you how to do it. Right? Mm-hmm. Mr. Harbin and Mr. Nelson will help. Mm-hmm. Are we in 4.4? Yeah, that's it. Okay. Go ahead and write that table down. And I think you can see those. If you can't, then move, because I don't want to go up and down and then I can't write. 81, 80, 33, 15. 15, 15, 5, and 6. Are these large numbers or small numbers? Small numbers. Because they're not 3 digits. And I tell students 200 or more on the bottom and the top. 81, 80, 33, and 15. 15, 15, 5, and 6. And the groups, the blood groups are O, A, B, and AB. And then RH negative and RH positive. RH positive is on top and RH negative is on the bottom. And they want to know the probability that if you select 2 times out of the box, what is the probability that the subjects are both B and RH negative? So take your highlighter here, even though we're not doing the additive law, this is the multiplicative law, B and RH what? Now, there is an overlap here, but you're not going to subtract the overlap here. You're going to use the overlap. Because when you see the word both, that means you're going to use an overlap. All right. So how many people make up the whole thing? 250. Now, we also need to do 2 or 3 things here. One, we need to take a highlighter, take a red highlighter, and we're going to highlight with replacement. I'm sorry. You're right. I'm sorry. I thought it said RH negative. Up here, I can't see that. I didn't see that. I'm sorry. The horizontal line is more visible than the division than the vertical line. I just didn't see it. I'm sorry. I'm blind. Yeah. Okay. Let's just quit. It's all Bush's fault. I'll use 2 same colors. Oh well. 33 is our overlap. So 33 is both what? B and RH what? Positive. So 33 out of what? $33 over 250, Hubert. That's right, class. Thank you for the interaction. Always nice to have an interactive class. So that'd be 33 over 250. Now, what does without replacement mean? That means that the marble is going to go back in the bag, so we can use exponents. And how many are they going to pick? 1 or 2? 2, so that would be raised to the what? That's without replacement. With replacement would be 33 over 250 times what? Over. Multiply that also. And let's go with 3 digits, or 4, like they said. Let's go with 4 digits. I'm sorry. What?
Yeah.
I'm sorry. I told y'all I didn't want to teach that. With replacement is the exponent. Without replacement is what do you drop? I'm sorry. Thank you. After you teach 3 of these, it's kind of running together. Somebody give me 4 digits here.
097.
0174. All right, give me 4 digits here. Zero one seven five. So the bigger the numbers are getting, the more you're seeing what? Similarities. When you get to the next problem we do, you're going to see an even more similarities.
So on these, you only use the overlap, like you wouldn't add them up.
We're doing the multiplicative law. And this one is, they're asking you, the key word right here is two selected subjects or both. When you see both, you're going to use the overlap when you're in 4.4. Okay? When you're in 4.4, you're going to use the overlap if it says both. Not all your questions are going to say both. All right, that's a test question. Star, star, hint, hint. Let's find another test question. Oh yeah, we're going to have to do the drunk driver and drunk pedestrian. We always do that one. Okay, this irritates me. Every single class I've tried to find the dadgum CV problem, and I miss it every single time. There it is. It's the one that's checked. All right, write that one down. I'll blow it up a little bit. I ain't going to be able to blow it up much. You have a question?
I was trying to figure out that last thing, like Shannon's line up, do something like this question, that it was actually positive.
Yeah, it was.
Okay, and I never did see that.
I didn't see the positive. I thought it was a negative. And you don't have to write every single word. All you have to write is without replacement. 1,430 CDs, 590 are bad, and you're picking out 3. You want to find the probability of 3 good CDs out of that batch. If you pick 3 CDs out, and anybody in here that's worked in any type of assembly line type industry, there's a thing called quality management, and that's what this is, quality management. Seeing if you're putting out enough good stuff. Big numbers or small numbers? Big numbers. So you're not going to see much of a difference in your answers. Do it both ways. The first thing you want to do is find out how many CDs are good. And I think most of y'all can figure that out. call the roll so I can get that done. Oh, that's the wrong class. Did I not take attendance in there this morning? Go back. It's the wrong class. Should be there, 24. Brabazon, Bright, Brown, and Brown are here. Buchanan, Campbell is here. KO is here. Carlisle, Clayton is here. Cothran, she's finished. DeVoe is here. Evans is here. Freeman is here. Harbin is here. Harkness is here. Hawkins is here. Jones, Junkins is here. Kidd, Lane, Martin is here. McLean is here. Nelson is here. Powell is here. Schmidt is here. Scott, Stansel. Stansel's not here? Loser. And Stelling. We got that done. Bureaucrats are happy. I was going to pull up my math show today, but I couldn't get it to pull up. Y'all ever watch Numbers? Huh? No? It's a good show. Alright, the first thing you do is you take 1,430. Ah, that's terrible. I'll just write it. I was going to be lazy, but heck, I can't even be lazy. You got to find out how many are good. So that's going to be 1,430 minus what? 1,430 minus 590. Somebody give me that number. 840 are good. And I'm going to go down here and I'm going to do without replacement. And I'm going to do with replacement. So you can see that after you get into the 3 digits, especially after 200, you don't see as much of a difference between the 2 answers. So, without replacement means that you're going to put it in your pocket. So that means you're going to take one off each time. So that'd be 840 over 1,430 times what? 839 over, and then the last one. And what's that number? And give us 4 decimal places. And now we do with replacement, meaning 840 over 1,430 raised to the what? And somebody do that for me and give me 4 digits. do you notice this one is 0.202 and that one is 0.202? The further you get here and here, and it says round to 3 decimal places, that's why. Now, a lot of you say, well, Hubert, this one is 0.202 and that one's 0.203. There is a tolerance of plus or minus 0.001 above and below on the answer. How do I know that? Well, let me type in the wrong answer. And look at there. You can't see it. Hold on. What is the correct answer? The correct answer is 0.023 plus or minus what? 0.001. So my answer ranges from 0.202 to 0.20 what? 4. So as long as you type in 0.202, 203, or 204, you'll get the right answer. But the main thing is that you see that with 3 digits, you start to see the similarities between the two versus the first one we did, where one was 0.025 and the other one was 0.035. This means yes. Everybody understand?
One person should carry it.
One person said The rest of y'all just sit there. I don't know what I've done to y'all. I mean, I really don't. I tried to be nice to y'all. And y'all just be mean to me. We'll go back to this one. Nope. Let me find it again. This is it. All right, write that one down. This is a test question. All right. It says the principle of redundancy is used when system reliability is improved through redundant or backup components. That means the more alarm clocks you have, the less you're going to over what? Sleep. Now this happened to me about maybe a week or two ago. I can't remember. But I have 2 alarm clocks, one on each side of the bed. Why do I have 2 alarm clocks? Well, in my area, sometimes the power will go out just for a few seconds. And what does it do to all your timers? It resets them and they go to the blinking thing. So I have one that does have a little bit of a battery backup, but I have the other one just in case it happens and the battery, that one goes off and the battery backup kicks in on the other. And I have my cell phone set at the same time. But last week, we had one of those little flickers and both my alarm clocks were blinking. And this phone woke me up because woke me up. I'm glad it did because those alarm clocks would not. That is redundancy, having 3 alarm clocks instead of 2, or having 3 alarm clocks instead of 1. Now, it's kind of stupid to have 2 alarm clocks with no battery backup, because if the power goes out, then both of them are out. But one of them does have a battery backup, and you got to check the batteries on it and make sure it, stays fresh batteries. But cell phone is another good idea. Another example of redundancy with the alarm clock. The surveying exam that I have to take in October, or the end of October. You have to be there at 7 o'clock in the morning or 8 o'clock in the morning, and they close the doors at 8:15. And guess what? If you're not there when those doors are open, you can kiss that $300 goodbye, because you can't go in after 15 after. It doesn't matter if your clock says 16 after and theirs says 15 after. It doesn't matter. Or 14 after, and whatever the case may be. So I make sure I take an extra alarm clock, and I take my cell phone, and I set the alarm clock in the hotel. I don't want to kiss $300 goodbye. I want to take the test. So, redundancy does help with certain things, especially like alarm clocks, and especially if you've got to be somewhere and it doesn't look too good if you're late, then you might want to get another alarm clock. Okay, a lot of interaction there. So, 7.2% failure. They say, what is the probability that a student's alarm clock will not work? 7.2%. Well, why can't I put that in there? Because percent is not decimal. So I got to change the percent to a decimal, which means I got to divide it by what? 100, move it over. So 0.07 what? Y'all should not miss this problem. If I give you this problem on a test and you miss A, you do not need to tell anybody. Okay? Glad I got it right. All right, B. If the student has 2 alarm clocks, the same alarm clocks, that have the same probability of failure, what would that be? I'm sorry. I was doing the attendance. Thank you, Mr. DeVoe, for interacting with me. I appreciate it. 98% of the class didn't say a word. What do? Well, you could multiply them together, or you could what? Raise it to the what? Second power. So somebody raise 0.072 to the second power. What do you get? Give me 5 decimal places. 0.00518. I guess that's 8. 8. I heard ain't. And check answer. We got it right. What is the probability of not being awakened if the student uses 3 alarm clocks? 0.072 to the what power? What does that come out to be? All right, I want you to look at these 3. Go back to your empirical rule. What is unusual? What percent of the population is unusual? Go back to the empirical rule. Page what? I can't remember what page it's on. 103 is what I said. I thought it was on page 103. Could that be correct? What'd you say, Mr. Nelson?
It's what falls out of line with the
2 standard deviations. But what is the percent?
95%,
95 is normal. So what is unusual?
2.5%
Which is
growth.
5%. Remember that. Always remember that, because 5% will tell you a whole lot. 5% is what we call what? Unusual. Oh, I am about brain dead, people. I'm sorry. Now, if you go on out 3 standard deviations, the percentage is like 99 point something. So there's a, 99.7. So there is 0.3%, and that is like 0.3%. Let's put that down. 0.3%, or what, or 0.17 on each side, or 0.15 on each side. 3% is what we call what? Outliers. Now let's change these to decimals. What is 5? 1, 2, so 0.05. So I like to tell people a nickel. And what is this one? That's not even a cent. So if you get any numbers that come out to be not even a cent, then they are what we call impossible. A 300-pound second grader is just about impossible. You know? Not these days. With all the Twinkies and stuff that everybody eats. 300-pound second grader would be just about impossible. This is when you're talking about standard deviations. When you're talking about percentages and decimals, we're talking about unlikely and what? Impossible. So let's look at our numbers. What is this one? 7 cents. So is that unlikely or is that impossible? It's unlikely, or around unlikely. What is the probability that the student's alarm clock will not work? Very unlikely that the student's alarm clock will not work. What about this one? Well, you could say unlikely, but I would say impossible. Why? Because you're talking 0.005. That's still not even 1%. I mean, 1 is rounded. Yeah, you could round it to 1, but it's still, these first two are not what? They're not, there's no cents there. And this one is impossible. I don't know what that last question asked, but we'll look and see. Do the second and third alarm clocks result in a greater improved reliability? Yes or no? 0.00 versus 0.00. No, not really. Hold on. I would say no. No, because you're talking, now this is my opinion, which I probably get it wrong. No, because the total malfunction would still not be likely, would be unlikely. And no, because the malfunction of both is equally or more likely than the malfunction of one. No, because the total malfunction would still not be unlikely. I would say this one, but I get these wrong all the time. So, see, probably yes. I don't even understand what they're asking. Do the second and third alarm clocks result in greatly improved? No, I don't think so. Huh? But the question, in my opinion, says, do the second and third alarm clocks result in greatly improving reliability? Okay, I'm looking at .00 as reliability. No, 99%. It would be 100% reliability on both of them, because what's the? See, I'm looking at it backwards. I looked at this as working. I'm sorry. This is not working, and this is not working. So if this is not working, and this is not working, what's the percentage of them working? 100%, right? Because this is 0 and this is 0. You might could say 99 here if you wanted to. So 99% and 100% working would do nothing but improve if the first one went down, right? And that's what they're asking. The way they ask it. I might change those to make the first part 0.9 and the D part 0.1, because I don't agree with making it half. Because the way they word the question, I don't like the question. Okay. All right. Y'all get out of here. Work on 4.1 through or 4.2 through 4.4.